Pretty much all stories involve characters, and specifically in 3D, if we want to tell our stories, then we need to be able to breathe life into our digital characters, and that's where animation comes in. Animation is hard and time-consuming to get right, but motion capture is something that can ease that process. Over the years, motion capture has become more accessible and straightforward, allowing us to more easily tell our character stories without having to spend countless hours animating manually, and instead capture the movement of our bodies and transfer that over to digital characters. ROKOKO is breaking down the gatekeeping by offering affordable yet powerful full-body motion capture solutions. Their Smart Suit Pro 2 comes in at around $2,200 and the Smart Gloves at around $1,700, but we actually purchased the ROKOKO Indie Bundle, which granted us 40% off the Smart Suit Pro 2, Smart Gloves, and Headcam, totaling at around $3,000 for the entire package. There's a chance you could qualify for this bundle if you meet the requirements, so check the affiliate link in the description to find out. They also have a free AI-based solution called ROKOKO Vision, which uses video to capture the motion alongside a free tier for their software. They were very kind to provide us with a 1-year pro license and an L-size textile for the suit, which we'll get to a bit later, and have even provided a coupon code for the ROKOKO Studio Pro license to give you guys a 5% discount. We'll mainly be focusing on the Smart Suit Pro 2 and Smart Gloves. Facial capture is a beast on its own, so we're gonna leave that for another video. I've modeled a character which will rig from scratch using free tools and some optional paid add-ons that are totally worth it and will speed up our workflow. But keep in mind that these add-ons aren't necessary to get to the final result. Then we'll put on the suit and gloves, use an external power bank to power them up, which isn't included by the way, connect them to the Studio app and Wi-Fi, capture some silly movement while going through the Studio app UI, and send that over to Blender for retargeting to our character. The Studio app has a feature that allows you to bring in custom characters instead of using the default Mannequin Model, but I found that to be a bit of a hassle because it requires a specific amount of bones and naming convention, which has been very inconsistent for me, so instead we'll take a look at how we can send live data from Studio to Blender and then retarget it to our character, which I found to be a much cleaner process. You can actually give this whole workflow a try without having the suit and gloves, as ROKOKO has a library of free mocap data to choose from, after which you can apply to this rigged model available on my Gumroad page. But let's now start with the base model and set it up from scratch. First, there are two rigging methods, rigid and deforming. The method we're going to use in this video is the rigid one, which means each individual part only rotates and moves instead of bending or stretching. You can watch this video from Doodly to get a better understanding of what rigs are and how they work. We first need to create bones to link the individual pieces of our object to. We'll hit Shift A to add an armature, which is going to contain our bones. Before we continue, with the armature selected, go over to Object Properties under Viewport Display, enable In Front, so the bones always show up in front of the model regardless of their position in 3D space. Now hit Tab to switch to Edit Mode. This can be our hip bone, which is usually referred to as the root. Let's go over to the front orthographic view and reposition it so the bottom part sits close to where we want our hips to rotate around. Now let's grab the tail and hit E to extrude. If you want perfect alignment, this is where the 3D cursor comes in handy. So let's tab out of edit mode, select the sphere, and with the origin set to the center of the geometry, we can hit Shift S, cursor to selected, which will move the cursor to the origin of the selected object. Then go back to the armature, in edit mode, select the head of the second bone, Shift S, selection to cursor. Now that bone will pivot from the exact same position as the sphere's origin. We can now continue extruding and repositioning the neck and head bones the same way. To parent the objects to the bones, we can select the hips, for example, Shift select the armature, Control Tab to go to pose mode, select the bone, Control P, parent to bone. And those were quite a few steps to parent one single object, and before that we had to extrude and reposition the bones one by one, and yet we are just getting started. From here we could duplicate one of these bones with Shift D, rotate it 90 degrees on the Y-axis, reposition the head and tail, extrude, and so on and so forth, and that would definitely work, but it's a bit time consuming. So instead, let's use this add-on called Bonera to speed up the entire process. Trust me, it is totally worth the price. Let's first delete the previous armature we made. For this workflow, you need to make sure the origin of each object is set to the location where we want it to pivot from. Now shift select only the objects where it would make sense to generate bones, such as the hips, spine, neck, head, arms, legs, and individual fingers. In addition to the middle parts, we'll only do the left side because we'll be able to mirror them to the right side. Let's hit N to bring up the side panel, which is where the Bonera add-on lives, and the top option you'll see is Create Bones from Selected. Ignore the naming because we're going to rename all of them manually in the end. We'll generate bones at each individual origin, we'll disable parenting because we'll do that at the end, and we'll call the armature Rig. Once we hit OK, we'll get this pop-up at the bottom left where we can tweak the size of the bones by setting the Z offset on the tail just for temporary visual clarity. Now let's set the transform pivot point mode to individual origins so we can rotate all the arm bones by 90 degrees on the Y-axis and scale the leg bones by -1 on the Z-axis. Now each bone is facing the way we want them, but they are still not oriented properly. If we enable the axes overlays under display settings, we'll now be able to see a gizmo at the head of each bone. By the way, the display settings are the same as the viewport display settings under the armature's object data properties. If we switch to pose mode and make sure we are in local transform orientations, you'll see that for the middle bones, when we press RX to rotate on the X-axis, they will rotate in the direction we want, but the leg bones rotate to the side. For consistency, I like to set the bone roll so they all rotate in the direction that makes sense when I rotate them in the X-axis. You can access the bone roll in edit mode under the item tab. To tweak this value for multiple bones at once, hold down Alt as you drag it and Control to snap to 10-degree increments, or write down 0 and hit Alt Enter. Now we'll do the same for the arms and fingers, so again select them all except for the thumb, write down 0 and hit Enter while holding Alt. The reason we left out the thumb is because we actually want it to rotate inwards. At this point, let's disable the axes overlays so they don't get in the way. Now we'll parent the head to the neck by first selecting the head, then shift-clicking on the neck, Ctrl-P, keep offset. And because we need to do this multiple times, we can hit Ctrl-P again, then right-click on the Keep Offset function and add it to Quick Favorites. Same for the Connected function. Now we can quickly access those functions with the Q key, so we'll continue with the rest of the chain. We're doing this because, of course, we want to have a parent chain that makes sense, but also because Bonera has this utility function that will align each parent bone tail to the child bone head, and we can even connect them. We'll do the same for the leg, arm, and fingers by again starting from the lowest bone in the chain. Now the naming convention is very important because that's how the ROKOKO add-on will be able to identify the bones when building the bone list. These are the names I ended up using. You can check out this Blender documentation page to learn more about bone naming. For arms and legs, we can select all and hit Ctrl F2 to batch rename, set the data to bones, type to set name, add the suffix .l, and hit OK. Now we can right-click and symmetrize, which will mirror all of those bones to the other side, and change the suffix to .r. Now that we have the bones, it's time to parent each object to the corresponding bone, which can also be a painful process, but there is another life-saving add-on called Parent to Nearest Bone, and this one is totally free, so huge thanks to Pablo. Select all objects, shift-select the armature, right-click, Parent to Nearest Bone. Now if we go into pose mode, you'll see that most objects were parented properly, but there might be some mistakes here and there, and some objects might not be parented at all, so we are gonna have to do some manual work, but we already have a good start. At this point, let's switch the viewport display for the bones to stick, just so it's easier to see and select things. Let's select the arm joints, for example, by holding Shift to add to the selection, Shift select the armature, Control-Tab to go to pose mode, Control-P, parent to bone. We can add the parent to bone function to quick favorites as well, and to further speed up the process, select the armature, disable lock object modes, go into pose mode, and this way, when you control-click an object, then click back on the armature, it will remember the last used mode and automatically switch to it. Now we go back and forth checking which objects aren't parented, parent those to the correct bones, and reparent objects that were parented to the wrong bones. And there we have it, the rig is complete. Now we can move on to ROKOKO Studio and start capturing some motion. For the Studio app and devices to communicate, we need to make sure they are all connected to the same network. A regular home router should work fine, but it's highly recommended to use a dedicated router for motion capture to avoid any lag or interference. In my case, I'm using this portable wireless router, which has a built-in battery, so it's very convenient. This router doesn't even have internet, but that isn't an issue because all you need is a network. So on my PC, I'm connected to this network via Wi-Fi, and for internet, I'm using a LAN cable from the office router. Let's open up ROKOKO Studio, plug in the Suit Pocket cable into a power bank to give it power. The power bank I'm using is from Anker, which is what they recommend, and I'll leave a link to a few models in the description. And connect the Suit hub located in the lower back pocket to the computer. Once the device is connected, you might have to update the firmware as shown here. Now let's go over to the Wi-Fi setup tab, choose the network, enter the password, and hit connect. You shouldn't have to touch any of these advanced settings, but they are available in case you need to make changes. Once the Wi-Fi connection is established, you can disconnect the cable, and from this point on, as soon as you power on the Suit, as long as the network is available with the same password, the Suit will automatically connect to it. Just make sure your computer is also connected to the same network. We can repeat this process for each glove independently or by connecting them to the Suit cables if you have the glove-ready model of the Suit, which has these cables coming out of each sleeve. The models we have for the Suit and gloves are M size, and earlier I mentioned that ROKOKO sent us an additional L size textile for the Suit, which has to be purchased separately. So depending on the person who's wearing it, we have the option of transferring the sensors between the two textiles, which is demonstrated in this video. There are a bunch of straps you can tweak for more comfort. It feels durable and not like it's gonna rip after some more extreme movements. The textile can be washed by following instructions on the tag, but of course you would have to take out the sensors first. You can't wash the smart gloves though, as the sensors can't be removed, so if you're gonna use them often and think that your hands might get sweaty, then you could use these disposable gloves before putting them on. Now let's create a new project and scene, add in an actor preset. This one is based on my body measurements. I've actually found the additional measurements to be very important in order to avoid any body parts overlapping with each other, so take your time by following along with this video and make sure you get precise measurements. Then drag the devices onto the actor, and once we do a calibration, we'll be able to see our digital self. We'll create a new folder to store the recordings and hit record. The fun can now begin. Once we're done recording, we can play through the animations and check to see if there are any issues. Sometimes the app thinks the foot is either in the air or has touched the ground when it hasn't, so we can tweak the foot locks in and out points, and ROKOKO will give you an updated animation after it finishes processing those changes. This step is quite essential for cleaning up the mocap data. There are useful filters such as the elevation tracking in case there is vertical movement, and the treadmill, which is useful for walk or run cycles. Please keep in mind that some features might be tied to specific tiers, so if anything is grayed out for you, then it might be a license limitation. Once we're happy with our animations, we can move over to the Export tab, where we can choose to export one or multiple animations at once. Choose the FBX file format and binary, and use the Mixamo skeleton because it has a simpler bone structure that better matches the rig we created compared to the other skeleton options. Finally, let's set the desired frame rate, and even though it caps at 100 FPS, we can actually go up to 200 FPS if we enable boost mode before recording. If you want, you can save these export options as a preset for later use, but let's now hit export. Back in Blender, we'll hit F4, import FBX, and the only option you need to check is the automatic bone orientation to avoid any weird bone rotation. If we want to move the rig, then we need to delete the position, rotation, and scale keyframes on the armature. At this point, we need to make sure the ROKOKO Blender plugin is installed, which you can find over at ROKOKO's website alongside plugins for other 3D software. This plugin even speeds up FBX importing, so that's a nice bonus. Now let's bring up the ROKOKO panel, set the ROKOKO armature as the source, our rig armature as the target, and hit Build Bone List. If you name the bones properly, then for the most part, each bone on the list should be mapped correctly. But if you get any errors or notice any mistakes, then just tweak the bone list and you should be good to go. You can show the bone names for both armatures to get a better idea on which bone should be targeted to which bone. You can hover over any field and hit Ctrl+C to copy, and hover over another field to paste with Ctrl+V, or delete a bone from the list altogether. Once you're finished, you can export that custom naming scheme for later use, so you don't have to re-edit the list every time for this specific character. We can now choose to auto-scale the armature to better match the scale of our rig armature, or we could do it manually by roughly lining them up. This doesn't have to be ultra precise, but the closer they are, the better. Then we can decide which pose of the source and target armature to use when retargeting the animation. Finally, let's reset the position of the ROKOKO armature to the center and hit retarget animation. And there it is. The reason we set the position of the armature to the center prior to retargeting is because our target armature will move to the source armature after retargeting, but we can move the source armature after the fact for a side-by-side comparison. My usual next step is to smooth out the keyframes in the graph editor just to get rid of some jitter that is sometimes present in mocap data. So with the armature selected, switch to the graph editor, hit A to select all keyframes, go to Key, Smooth, Smooth Gaussian. And I like to drag this up to no more than 10 or 20%. This is a destructive method though, meaning we lose the original raw mocap data. So either make a backup of the armature by duplicating it before smoothing out the keyframes, or you could use this wonderful animation layers add-on, which behind the scenes makes use of actions and the non-linear animation features, which I'm not going to dive into, but you can watch this wonderful video from Joey Carlino that breaks down how those work. As for the animation layers add-on, with the armature selected, you can enable it, then hit plus, which will create the first base layer, so the raw data, and another layer on top where you can make adjustments to the animation without touching the original data. But first, let's duplicate the raw layer and call it smooth, then switch the blend method to replace, which will replace the animation layer underneath, and with the smooth layer selected, select all keyframes and smooth them out like we did before. So we smoothed out the keyframes, but we still have a backup of the untouched keyframes. Additionally, we can create another layer on top with the blend method set to combine, which we can use to make tweaks to the bones in pose mode. This is especially useful when we want to get rid of any overlap. Actions and animation layers are essential tools for animation in general, and that especially includes mocap data. The animation layers add-on only packages these Blender features in a much more intuitive UI, so I highly recommend you check it out. Blender's development team is even working on bringing us an updated version of the action editor and animation layer system, which is very exciting. Let's now take a look at how we can capture animations while previewing how our character moves in real time. Back in ROKOKO Studio, go to the Streaming tab, activate the Blender module, and you should see the live overlay. In Blender, hit Start Receiver, and the ROKOKO actor should pop up. Then with the armature selected, go to Object Data Properties, under Attach to Actor, choose the actor, and hit Auto Detect to build the bone list or import a previously saved naming scheme. Now when we hit Set as T-Pose, our character will start to receive the data. There are even a few command APIs such as calibration, start and stop recording, so you don't have to go back and forth between Blender and Studio. You could record directly in Blender, but to get the cleanest data possible with no lag, it's best to use ROKOKO for recording and only use Blender for preview purposes. And it might seem a bit anticlimactic, but it really is that straightforward, and I think ROKOKO has done a phenomenal job in terms of simplifying the whole motion capture workflow. Before we wrap up, I wanted to talk about a few things you should be aware of when working with the SmartSuit Pro 2 and Smart Gloves. They use inertial-based tracking, so they aren't aware of the exact positioning in space, so you might end up with body parts that overlap each other. There is some drift over time, so you will have to recalibrate often, and there is a chance of electromagnetic interference depending on the environment you're recording in. You won't always get perfect results right away. You will have to maybe put in some manual work like we did by correcting footlocks, smoothing out keyframes, and correcting bones so they don't overlap with each other, but that's just the nature of motion capture. To combat these issues, ROKOKO has released the Coil Pro, which will remove any drift and overlap issues for the gloves as it creates a 5-meter electromagnetic radius that tracks the absolute position in space. This in turn helps out the suit to be more accurate as well. But don't take my word for it, grab this model and some mocap data, download ROKOKO Studio and give it a try yourself. Again, don't forget to use the coupon code for a 5% pro license discount and use the affiliate link in the description in case you decide to make a purchase, which will also help us out with a commission. Thank you for watching and take care.